So let's talk about momentum and collisions. And I know that it's easy to get caught up in thinking that momentum is this really massive mathematical thing and it's really complicated, but it's not. There's two ways to understand momentum. One is to say that momentum is an object's mass and its velocity put together. And that's a really good way to think about it when it's already moving. Okay, so if something's got a small mass but a really high velocity, it's still got a high momentum. And this is why things like bullets or shrapnel or fragments can still hurt people. This is why a stone flicked up off the road can shatter your windscreen, because even if it's got a small mass, it's got a high velocity. So it's not very useful. It's not that useful to consider collisions in terms of the mass times velocity part. That's useful for understanding that a large object has a lot of momentum, even if it's moving slowly, but a small object can still have a lot of momentum if it's moving fast enough. I think a better way of thinking about it in terms of collisions is to think about a force times a time, okay? And I want you to think about we're starting a movement, starting something moving. Here's our car. And we want it to move forward. We want it to have momentum. So, how do we give something momentum? Well, we apply a force to it. So if we take this car and we push it, we will give it some momentum. We have applied a force to it. Now, we can apply a little force for a fairly long time and we can get some momentum out of it. We can apply a big force for a short time and get some momentum out of it. So this here, force times time, is often called or given the special science name of impulse. And I want you, when you're thinking about impulse, I want you to think of it in terms of starting and stopping. And the reason for that is that usually when we talk about impulse, we're talking about things gaining or losing momentum, either from zero to their final velocity or from their final velocity to zero. We're talking about things speeding up and slowing down. We're giving them a force over a certain amount of time so they have momentum. So let's think about playing sport. And I trust you're familiar with the idea that someone can throw, say, a tennis ball. They can throw it gently or they can throw it hard. And so it takes the same amount of time for the ball to be accelerated with the arm moving, but they can put a lot of force behind it or a little bit of force behind it, depending on how they use their muscles. When the ball hits you, then, if it's got a low amount of momentum, when it hits you, your body will start to absorb it. There's a certain amount of time that your body will take for the ball to sink into your skin, and it'll get you fat in your muscles or will move out of the way and spring back against it. If that's a long time, then the force it hits you with won't be very big. But if that's a short time, the force it hits you with will be really, really big. So all the momentum has to get used up when it hits your body. All that momentum has to get used up somehow. Your body has to absorb it somehow. And so if you experience a large force over a short time to use up that momentum, that's going to hurt a lot. On the other hand, if it takes a really long time to slow down, so say you're wearing something spongy and springy or you catch it in a glove, the force is smaller. And the same thing happens in cars. So let's say our car is moving along and it hits something again. Here's our car. And when it hits the wall, we want to make the momentum go to zero over a really, really, really long time. We want the car to take a long time to interact with the wall. And you'd know that if you hit a wall, it hurts. You hit it, you stop, it hurts. But we can make it take longer. And one of the things we can do is the car can crumple up. Because that crumpling takes longer to happen, the car slows down slower. And therefore, there's less force on the car and therefore less force on you. And a good way to think about this is if you're dropping an egg, if you wrap the egg up in something like bubble wrap and then you drop it, it doesn't break because the bubble wrap absorbs the impact. It takes more time for the collision to occur. Airbags are another example. If there was an airbag in the car and it blows up, if you hit the airbag, it's soft and squishy. So when you hit it, here's our person hitting the airbag, when you hit it, the airbag's soft and squishy, and it takes a long time for you to slow down into the airbag. You won't get injured as much. So those are two ways of thinking about it. The third way of thinking about it is in terms of stopping distance. So here's our car, and let's say this time that they see the wall coming. They're a long way away and they see the wall coming. What do? Well, they brake, don't they? They apply a force with their brakes to slow them down. If they have a lot of momentum, if their velocity is high and they apply their brakes, it's going to take them longer to stop because they have more momentum. So your brakes can only apply a certain amount of force depending on how they're made. So if your brakes are really, really good, you can stop faster. But if you're going really, really fast, you'll have such a large amount of momentum that even really good brakes won't stop you in time. So there's two related things here. One is, if you are speeding, if you are going fast, you will have a lot of momentum. The only way to get rid of momentum is to apply a force for a period of time. You do that by braking. If you're going really, really fast, your brakes can't slow you down in time. You might still hit the wall or have that collision. On the other hand, if you're traveling at a reasonable speed, you will slow down in a shorter distance because you can apply the force from your brakes and they will slow you down. If your brakes are worn, or your tyres are worn, so there's less friction force between the brakes and the tyres or between the tyres and the road, you can't apply as much force. So even if you're traveling at a reasonable speed, even if your velocity is reasonable, you'll take longer to stop if your brakes are worn because they can apply less force. So I hope that's helped you understand how momentum works.